Welcome to the launch of the next mini project, and that is cooling the Tesla battery modules. They are water cooled, therefore you need something to radiate the heat away that has an active fan on it. You need a pump to pump the water through here so that the water goes through the modules and eventually back here and out again. Then you need a tank to hold fluid that's pending, and then you top it up. Please feed the YouTube algorithm by giving the video a like. If you want to see more like this, click subscribe and ring the bell to be notified of new videos. If you want to chip in on my expenses, I now have Patreon and YouTube memberships. They're pretty small. I mean, this is the size of my palm, a little bit bigger. Technically, it's called an oil cooler from Setrab in Sweden, and I was thinking like, oh, I gotta go get a 12-volt battery and figure out which way the fan is spinning, and then I turned it over and I saw this note from myself: airflow this way loud. So I want to mount it like this so the air goes out the back of the car. And it's got 4 really good mounting tabs that should give me a lot of flexibility for my mounting strategy. I got to figure out if the hose or the ends should be pointing up or pointing down, or if it matters. And this is a Bosch pump with the mounting bracket that I ordered special for it, which is great. And depending on how I build this, I should be able to mount the pump somewhere here. So the fluid comes which way? Fluid comes in here and out here. So wants to go like that, and then out. So let's see what we can think up. It's definitely doable. I would say 90% of the work is already done, except this one involves mechanical engineering, which is not my strong point, but we'll make it work. We've got a bracket that we can bolt to here. We've maybe can bolt onto the plate, the adapter plate between the motor and the transmission. I've got a bolt here. I've got a bolt up there. No, that one's not going to help because it's touching the box. Maybe I can attach something to the battery box. Or we could look at this side. I'm going to try and stay over here. But let me start mocking this up tomorrow. It's the end of a brutally cold day. Last night it was 4 degrees out. And that's Fahrenheit. 4 degrees Fahrenheit. Wind chill felt like -7. That is like freeze your fingertips off in 20 minutes kind of weather. So that was fun. My little cottage I'm staying in was doing a very hard time trying to keep up with keeping things warm inside, but Jackie gave me another space heater, and it seems to be going well. So, adventures in Missouri in January. But luckily the shop is nice and warm because there's a giant heater right there and another giant heater right there. So the shop is the warmest place. Maybe I should just throw a mattress and a sleeping bag down on the floor here. All right. Anyway, let's get this kicked off in the morning. Okay, this is where we are now. I didn't want to take you through too much of the measuring and bending and cutting and drilling, but I'm starting with this beast of a mounting point, which is the pivot for the rear suspension. Comes to this L-shaped bracket, which goes to another L-shaped bracket, which holds the bottom of this in place. Bracket number 2 is roughed in from the mounting point on the adapter plate and the motor and the transmission over to here and then over to here. You can see it's That's not even bolted in, and it's pretty solid right now. But now I want to make one that goes across the top to prevent this kind of thing. Okay, let's keep going. Okay, with the radiator bracket done, I'm going to mount the pump here. I'm going to use this top bolt and make another hole here. Hopefully get a nut on it on that side. So I got to take that off. Well, look at this. These used to be two separate pieces of metal before I unleashed my new welding skills and then ground and polished them to a fine shine. This one was also two pieces of metal, and we now have two brackets ready for painting and installation. I spare you my learning to weld again, but the secret was I did have it plugged in to the wrong voltage plug. I did a 240 this time, cranked up the DC amps to 190, and it was actually pretty easy. I mean, the rod melted beautifully. I had to go back and fill in a couple of gaps that I left, but otherwise I'm pretty happy with the way these turned out. And to support this little 5-pound fan with 3 different attachment points, it's going to be fine. So let's give them a coat of paint, and tomorrow I'll start bolting everything in. And here we are after a coat of paint. Almost looks like somebody knew what they were doing. Here's the top bracket, been drilled and painted. So all the bracketing is done. Now I'm going to install the pump right here. Okay, I bolted the water pump into place, one with the existing bolt for the bracketing, and then I drilled another hole. On the downside is to get to the nut position is incredibly tight. So I actually held the nut in place with a piece of black tape and put the wrench behind like that for it to catch. It worked. So now I'm going to put the top bracket in and work my way down. And the fan is completely bolted in. It's top bracket, bottom bracket, bottom bracket, and this thing is solid. It is not going anywhere. And the water pump, oh, you can't see the water pump. There it is. The water pump is mounted back here. There's a slight gap between the fan or the radiator housing and here, but this is a rubber gasket, so it's essentially, even if they touch, it's isolated. And I pre-wired the connector on there because it's so tight. And so what I need to do is get these wires to come into here and hit the fan, and then pick up the 12-volt feed from the relay, which is this cable harness. And we are fully wired up. The main cable comes in, goes to the pump, and it goes to the fan. This is pretty stiff wire here, and everything is zip tied all the way back. So all I got to do is test it by engaging the relay that turns that on, which is supposed to be driven by the V2. I may have to just touch a wire somewhere and see. Alright, turns out that there are secret commands in the V2 console, and if you just type a 5, it'll turn on the heat enable signal. So let's go over here. And then I hit a 5 and listen. Now, what's interesting is I hear the relay click over here, which is part of the logic that drives the fan. We can hear the fan, and I think the pump, I think both of them are spinning up, and then after about 2 seconds it just shuts down again. And it says heat enable is now off. Now I don't know if this is like it only supposed to do that, And the heat enable was on, and now the heat enable is off. So I'm guessing it's just a momentary thing to do exactly the kind of test I'm doing now, which is pretty cool. That means all of that wiring, all the logic, the relay, and both the fan and the pump are working. All right, so tomorrow it's plumbing time. Okay, let's talk about the cooling loop. I just drew up this more formal diagram from the really sketchy one I had before, and just to firm up how I'm going to do this. So the fluid goes from the back to the front through 3 modules, to the rear through 3 modules and out. Now, some helpful people made a comment that instead of doing these in series, I should make a manifold that feeds all 3 and then a manifold that takes the outgoing water. I think this is interesting because the water's going to get sequentially hot as it flows through the system. This pack is going to be, our module is going to be far hotter than that one. If I had 2 manifolds, this one would be, say, warm, and this would be a little warmer. But I think given my use case of this is only going to kick in when I'm driving the thing hard, it's just not going to happen. And I'm going to watch for this, and if there's an issue, then I'll switch to a manifold design. But I don't want to re-engineer something that I haven't proven doesn't work at this point. So these are all running through an 8mm hose, which is about 1 millimeter too small because of the damn fittings on the Tesla modules are extremely hard to get on. But anyway, then my strategy was to have the pump be the outgoing of the pump pushes it with the highest pressure, pushes it through the modules and to the back. Now, the pump, 18mm fitting going out, I got to get a 8mm fitting going in. When the fluid comes back, it's going to go into that coolant bottle. Coming in at the top, there is a 10mm fitting, and that 8mm hose is definitely not going to fit on a 10. So I'm plan to change this short run, about 6 feet long. That's going to go to a 10mm fitting. It'll be easier to get on here. Hose clamp, that's good. Then, coming out of the bottom of the bottle is an 18mm fitting. Don't know why they chose to use 2 different sizes. Now, the bottle will run into the radiator and the fan, and then to the pump and out. So I've got to make a transition here and a transition here. The bottom of the radiator has this fitting on it. This part is screwed into the bottom of the radiator. This part comes out onto some sort of a compression fitting. So what I'd like to do is either, or probably better, just to have an entirely new fitting that's the same as this but can accommodate an 18mm hose in whatever fashion the company can get that for me. And that'll make me happy. And then going out the same way, luckily, it goes out to an 18mm fitting on the pump. So I just need 2 of these, match this, and 18mm hose here. It's Sunday afternoon. I'm going to take the rest of the day off, and on Monday I'm going to go talk with the happy folks at Napa, with their hose experts, and we'll see what we can work out. Welcome to Monday morning. I just spent a couple hours with the guys at Napa, getting a lot of the fittings and things I needed. This is concentrated coolant. You have to dilute this 1-to-1 with water, G48 for Tesla systems. This beautiful piece of brass is the replacement for this fitting, which gets me to the 18mm hose. This contraption is an 18 to 8mm reducer, which lets me fulfill that need right there. This is going to go here. just an 18 to 18, and this is the hard right turn that I need for the coolant bottle, because when I tried to use my hose it kinked like that, but this stuff is pre-bent, so that's pretty cool. Some hose clamps and some 10 millimeter to go in this section. So let's start putting things together. So here's the first fitting out of the radiator and into the pump, the intake of the pump. And to make this bend, I left a lot here, but the material of the pipe isn't very strong and it was buckling here. So I added this little clamp to keep it round, and it's gonna bounce around a little bit. Not sure what I'm gonna do about that. I've got the outlet of the pump, goes through this Franken compressor from 18 millimeters to 8 millimeters and out the hose to the front battery module. This one comes back and goes to the second batch of modules. What I need to do next is to have this come out and go across there to the coolant bottle. Otherwise, everything's pretty cool. Here's the thing. You don't realize how big this is. This is like 4 different pieces of brass to go from 8 to 18. And I'm holding it in with zip ties. Is it tight? Yeah, not really. But I think maybe I'll put some of those metals, this kind of metal strap on and hold it in place, but it'll do for now. I had to go back to Napa for some extra parts, so I picked up some 3/4 inch hose with a much stiffer sidewall, and this is not going to come apart here or crimp down. It's nice and strong. It's going to flap in the breeze a bit, but it's good. Okay, we're back up top, and we are now connecting the last sections to the fill bottle. Bottom one, 18 millimeters, goes to the other hole in the radiator, and I've got a really sweet right angle pipe that I got from Napa for that. This top one, 10 millimeters, goes to the outlet of the top battery pack here. Will go down underneath and then come up and connect to there. And then this one is just an overflow drain. Okay, 3 pipes hooked up, going down below, and the one comes up right there and the other 2 are underneath. So let's go set them up. The easiest one, the overflow drain, comes down here, same as its twin sister that goes up to the drain on the charging socket. The 2 pipes come through here, across, and this one goes straight into the radiator. The other one goes across here and up into the battery box. Zip tied the living crap out of everything, and hopefully nothing moves around too much, but it looks pretty solid. I'm pretty happy with the way this turned out. Now all I have to do is go upstairs and attach 1 more pipe. I just made the last connection right there. We should have a complete cooling loop. That's pretty cool. Sorry. I'm going to wait till the morning to add any liquid to this because it's been a long day and I want to have a sleep on it and see if I forgot anything. So tomorrow is the day. Good morning. Here's where we start having a lot of fun. This is the coolant G48 as specified by Tesla to go in the Tesla car. And since I got Tesla modules, that's exactly what I'm going to use. Now, the interesting thing about this is it comes concentrated, and you have to mix it 1-to-1 with water, just regular water. It doesn't need to be distilled water or anything. So what I'm going to do is use this measuring cup. I'm going to go half water, half coolant, stir it, pour it in, and do that several times until we get enough in the coolant bottle, and then we'll turn the pump on and see what happens. Well, I put the first 750 milliliters of coolant in and I got a leak already. I'm not surprised. I had to take this fitting out, and I think that the Teflon tape got messed up. And this is going to be a difficult one because the coolant's going to go everywhere. It's at the bottom of the loop. Oh well, that'll be fun. All right, I buttoned everything back up, put the liquid that I caught back into the system, and I've got another drip. Oh, this is going to be a problem. Okay, this is nice and dry that I fixed, but the problem is the leak is coming from here, which I think is in the frame of the radiator itself. Now, was I a dummy and not tested this when I took it off the shelf? Yeah. So, this is really bad news. I gotta see if I can figure this out. Okay, I got it pulled out of the car, took all the brackets off, all the hoses, all the electrical, and took it to a radiator repair guy. He says it's a lot like the oil coolers that he works on, and he's had a lot of good luck with those. It's going to take him a couple of days to get to it, and then he'll let me know if it's got any possible future life. So we're on pause for this for a while. I'll go find something else to work on. All right, I got a call from the radiator guy. He said it is completely unrepairable because the crack is somewhere up inside here, inside this housing that he cannot just get to. So, off to buy an identical one from the internets, and I will just bolt this fan onto the new one, save myself half the price of a combo unit. Alright, it's Monday, it's happy day. New radiator has arrived. Need to swap these fittings over to here. Paying special careful attention to double wrench them on like the radiator guy said. Then we'll install the brackets and stick it back up in the car. Oh, and put the fan on too. Alright, the fittings are on. I did a leak test, sealed up the fittings, and no leaks. But I haven't done a pressure test. Hopefully it'll be alright. The new radiator is in with the old fan and the old fittings. Everything's connected and tight except the two bottom brackets, so there's a little bit of wiggly, but I don't want to just do that if I have to take it all apart again. We're ready for leaks. Let's go. Alright, not a drip in sight anywhere on the ground. Nothing is leaking up here. I put in all the liquid that I recovered from my first attempt, which is maybe about 1 liter. So, looks pretty dry. Well, we're not under any pressure yet, so let's keep filling up. And that's another 700 milliliters, 1.7. I have no idea what the capacity of this thing is going to be. We're just going to have to experiment. Well, it's a good thing I checked. At 1.7 liters, the tank is almost full. So now is the moment of truth. I get to turn on the pump and watch for leaks in the rest of the plumbing. Well, good news and bad news. I put 3 more bottles worth into here, but now the level is not dropping, but we're not getting any return through the system. So it's getting to a certain place and it's not able to pass. There's no leak here and there's no leak there. So I'm hoping I can just go drive it around and get everything warmed up and maybe the coolant will start to flow. Well, slowly but surely, it's used up another entire can of coolant, which you can't see. So I get to put another cupful in. Well, tried to put another full 700 milliliters in, and I know the overflow tube works properly. So I used the V2 console to manually turn on the heating and cooling system, so you hear the fan blowing and the pump is running. And you can't see it here, but I see a small amount of fluid is returning to the bottle. So I'm going to call this done. It's less flow than I would have hoped, but it perhaps has to do with the way that I ran them all serially through them instead of having a manifold in and out for each of them. But I will keep an eye on the temperatures, and I will take action if I get concerned that they get too hot on the short drives that I'm going to be taking. So I'm going to call the cooling system completely wrapped up. Just before we wrap up, I want to thank my Patreons, Peter Bouvier and Puppy, for their support. We also just popped over 2,000 subscribers, which is quite a nice milestone for my little channel. All support is greatly appreciated. Hey, I hope you enjoyed the video, and if so, please give it a thumbs up. I see that 81% of the viewers aren't subscribed. Please do, as it does help the YouTube algorithm. Take care and see you next time.